The Himalayas, abode of snow, is birthplace of several river systems in Asia, including Indus, Ganges, and Brahmaputra. Dynamic storage of frozen water in the Himalayan glaciers provides a significant amount of water to these river systems. More than 900 million people of South Asia depend on these rivers for their water requirements, for irrigation, industries, hydropower generation, and local water supplies. Recent studies suggest that Himalayan glaciers are losing their water storage at alarming rate. However, the understanding about climate-glacier interactions is still partial. One-third of the Himalayan glacier mass is expected to be lost by the end of 21st century. If we can limit the global temperature rise to 1.5 degrees Celsius above pre-industrial levels, as suggested by Paris Agreement on Climate Change, these glacier changes will bring impacts on total annual stream flows in the Himalayan river systems, including seasonal distribution of runoff, which is critical for irrigation and economy of some of the fast developing countries of the world. Muhammad Farooq Azam, Assistant Professor at Indian Institute of Technology, Indore, is among few scientists who are working to understand the impact of climate change on Himalayan glaciers. He is involved in comprehensive glaciological research on Chhota Shigri Glacier for almost last 10 years.
The research on Chhota Shigri Glacier was started in 2002 under Indo-French collaboration between Jawaharlal Nehru University, New Delhi and Institute for Research and Development, France. And I started my research career in 2008 on this glacier as a master's student.
There are intrinsic challenges in Himalayan glaciological research. Mostly, the glaciers are located in remote areas and scientists have to drive on extremely dangerous roads or walk for days. The weather conditions are unpredictable and may turn bad very quickly.
There are challenges in any kind of glaciology, but in the Himalayas, glaciers are located at very high elevation. They are difficult to access sometimes. What is important that's the largest glaciarized area outside the polar regions. So compared to the Alps, for example, you have 50 times more glaciers in the Himalayas than in the Alps. So it's a challenge to study them because they are spread over very large areas with different climates. So if you are in Pakistan, or if you are in India, or if you are in Bhutan, the climate is totally different.
दुईबाट यहाँ काम गरिरहेको छु यो छोटा सिक्रीमा मुस्किल त धेरै जसो आउँछ यहाँ मौसम कति बेला खराब हुन्छ थाहा हुँदैन बिरामी भयो भने कुनै सानो चीज किन्नलाई हामीले मनाली पुग्नुपर्छ अनि बिरामी भएको बेलामा सानो दबाईको लागि पनि मनाली पुग्नुपर्ने हुन्छ त्यसैले पहाडमा काम गर्दा कठिनाइ धेरै आउँछ समस्या धेरै आउँछ हामीहरु यस्तो यो पत्थरले बनाएको घरमा अलिअलि तिरपाल लगाएर यसैमा बसिरहेका छौं बरफ गिर्यो भने यो दब्न पनि सक्छ त्यसैले समस्या आउँछ हामीहरुलाई धेरै समस्या छ पहाडमा काम गर्दा
Farooq's team reaches Manali, which is the last town where they can have good food and shower. He quickly arranges some potters and cooks for the glacier expedition. In Manali, team carefully prepares all logistics for the expedition before moving in deep mountains. Journey towards Chhota Shigri Glacier starts at dawn to avoid traffic jams. Team ascends slowly through zigzag roads and reaches Rohtang Pass. The other side of Rohtang Pass is Chandra Valley. The road here is not paved. High altitude meteorology is one of the biggest Unknowns in Himalayan glaciology. Farooq has installed a series of meteorological stations in Chandra Valley. He checks and downloads meteorological data from one of the stations on the way to Chhota Shigri Glacier. In the evening, team reaches Chhota Shigri base camp. Next morning, Farooq carefully prepares the loads for Glacier high camp. Team members trek through small, big boulders, making their way towards Glacier. After trekking almost 1 hour, Glacier snout appears, which is resting in a deep, narrow gorge and covered by huge amount of rock dirt debris. In the afternoon, team reaches to high camp at 4,750 meters above sea level. Here, the oxygen is around 50% compared to sea level. That, coupled with low temperatures, makes everything challenging.
Glaciers are a direct indicator of climate change. In the Himalayas, only few glaciers are under observations. In order to understand the impact of climate change on Himalayan glaciers, scientists observe high altitude meteorology, glacier mass balance, change in its glacier ice thickness and dynamics, as well as glacier hydrology.
From the high camp, Farooq makes a hike to Littoral Moraine, where he has another meteorological station.
We reached this point, and the altitude here is 4,950 meters. We started from base camp, which is 3,850 meters. So we gained almost more than 1,000 meters of altitude, and we traveled almost, I think, around 7 to 8 kilometers on this glacier. So here we have this very basic stuff. Actually, I put this drum here to collect the overall precipitation, whether it is rain or snow. And besides, I also have here the temperature sensor and rain gauge.
Mass balance of a glacier is a direct reflection of climate change. During dry and warmer years, glacier ice acts as buffer to the hydrological cycle and release additional water in the river systems.
You know, there is accumulation of snow at high elevation, and through compaction, the snow turns into ice, and with gravity the ice flows down. It reaches lower elevation, and at lower elevation there is warmer temperature and it melts. So it's kind of balance between accumulation of snow, turning into ice, flowing with gravity, and turning into water at lower elevation.
At lower elevations, glacier melting is estimated by measuring the emergence of eco-friendly bamboo stakes inserted in the glacier during last year. At higher elevations, glacier accumulation is measured through drilling the snow accumulated since last year, sometimes in bad weather conditions.
We have this kind of core. Outside is this auger, and we measure the length of this core and diameter, and then we have electronic balance here, and we measure its weight. So like this we have volume and weights, and we calculate the density at different depths, and finally we calculate the accumulation at that particular point. With increasing recent attention of scientific community, the understanding about Himalayan glaciers has increased swiftly. However, this understanding remains poor compared to other mountain ranges of the world.
Il y a beaucoup de lacunes en glaciologie pour les glaciers himalayens, parce que d'abord les glaciers sont peu observés, donc on connaît assez peu les bilans de masse des glaciers, on les connaît par satellite, mais il y a très peu d'observations au sol, et c'est important donc de mesurer ces glaciers, d'en mesurer plus, Et c'est important de mesurer les deux termes des bilans de masse des glaciers, c'est-à-dire l'accumulation qui est directement liée aux précipitations, au terme de précipitations. Et c'est important aussi de mesurer la fonte de ces glaciers puisque c'est lié au réchauffement du climat.
Now it is clear that Himalayan glaciers are losing mass, which is consistent with global warming. However, glacier shrinkage rates are not uniform along the Himalayan range because climate varies from one location to other. And in order to understand the impact of climate change on the whole Himalayan range, we need to select more glaciers for observations from different climatic regimes in the Himalaya. And such local studies are also important for the development of large-scale models for future glacier evolution as well as runoff evolution.
Science has always been driven by money. The research in the Himalayas is expensive and needs continued long-term funding to understand the fate of these glaciers and future water resource management of the Himalayan rivers.